Hi everyone. In this video, we'll go through topic related to matrix method. Before going through matrix method, as a prerequisite, you should have gone through minus, cofactor, adjoint, and inverse of a matrix. So all these concepts of adjoint and inverse should be clear before you go through matrix method. Matrix method is a method or a technique used to solve linear equations, right? So if you have equations such as 2x plus 3y is equal to 5, 3x plus 8y is equal to 7. So these equations are nothing but linear equations. We went through Cramer's rule, right? We went through Cramer's rule. That is also a technique used to solve linear equations. That is, find out the values of these variables. X and y are called as unknowns or variables. That is, we don't know what x and y values are. So to find out these values, we use this matrix method technique, like we used Cramer's rule, right? Now, this 2 and 3, 3 and 8, these are called as coefficients. So any numbers next to the variable is called as a coefficient. So coefficient of x is 2, coefficient of y is 3. Similarly, in this particular equation, coefficient of x is 3 and coefficient of y is 8. So these are called coefficients. And these 5 and 7, which are just numbers, there is no variable next to it. There is no unknown, right? There is no x and y here, right? So these are called as constants. Using these coefficients, constants, we'll have to find x and y, right? Now, if you have linear equations of this form, so a1, a2, a3 are coefficients, b1, b2, b3, c1, c2, c3, these are coefficients. X, y, z are the unknowns, which we have to find out, right? Using this technique, we have to find the value of x, value of y, and value of z. And d1, d2, d3 are constants, right? These three are constants. We'll have to represent these three equations in the form of matrix. So let's take matrix A. Matrix A will have all the coefficients, just the coefficients, a1, a2, a3, b1, b2, b3, c1, c2, c3. And matrix X will have all the variables or unknowns like x, y, z. Then matrix B will have all the constants d1, d2, d3. Now using these three matrices, we'll have to find the value of x, y, and z. Formula for finding out the values of x, y, and z is this one. Matrix X is equal to A inverse into B, right? Matrix X is equal to A inverse into B. So we'll have to find A inverse, multiply it with B matrix, and then you'll get X matrix. You'll get another matrix which will have values for X, Y, Z. You'll get values for X, Y, Z. Let's take an example where we have to solve these linear equations using matrix method. Now, first step, we will convert these equations into matrices. So first we will have matrix A. Matrix A is nothing but the coefficients of x and y. So coefficients of x. First write the coefficients of x. So this will be x, this will be y, right? Remember this. The first column is x, second column is y. So for these two equations, 5x plus 2y and 7x plus 3y, we will write this one below the other so that it becomes clear. So 5 and 7 are the coefficients of x. 2 and 3 are coefficients of y, right? So we have matrix A. Now let's take matrix X. What is matrix X? It is matrix with all unknowns, right? Unknowns. What are unknowns here? X and y. We don't know the value of x and y. So we put x, y, right? And what is the next matrix? B. What does it have? It has constants, right? And what are the constants here? 4 and 5. 4 and 5. How do we solve the linear equation? The formula is x is equal to A inverse into matrix B, right? This is the formula. Now, how do we find A inverse? Let's call this as equation 1. How do we find A inverse? A inverse is 1 by determinant A into adjoint of A, right? So we find A inverse using this formula and then multiply and get matrix X. Now let's find determinant first. So determinant of A is cross multiply. 5 3s are 15 minus 2 7s are 14. So 1. This is determinant. Now what is adjoint of A? Since it's a 2 by 2, it's very simple. Adjoint is swap the diagonal elements. 5 and 3 is the diagonal element. So swap it. So you will get 3 and 5. Then you have the other diagonal elements. What we have to do? We have to just change the signs. So 2 will become minus 2 and 7 will become minus 7. So this is adjoint of A. Now let's substitute. A inverse is equal to 1 by determinant of A. Determinant of A is 1 into adjoint of A. Adjoint of A is 3 minus 2 minus 7, 5. Right? So 1 into 1, it's the same thing. So you'll get the same matrix back. 3 minus 2 minus 7 and 5. So this is A inverse. Now, we'll have to get this. We'll have to find matrix X, right? So we'll substitute matrix X is equal to A inverse into B. A inverse is equal to this particular matrix. It is 3 minus 2 minus 7, 5 into matrix B. What is matrix B? 4 and 5. Matrix B is having 4 and 5. This is 2 by 2, 2 by 1. So final order is going to be, the final matrix, when you multiply, you're going to get 2 by 1. This is the final order. So if you multiply this, the final order is 2 by 1, right? So 2 rows and 1 column. So 3 into 4 is 12. Minus 2 into 5 is minus 10. Next row, minus 7 into 4 is minus 28. 5 into 5 is 25. So plus 25. You're going to get 12 minus 10 is 2 minus 3. So matrix X is 2 and minus 3. Now this is nothing but X. This is nothing but Y. That's what we assume, right? X is, matrix X is X and Y. So what do we infer? That X is equal to 2 and Y is equal to minus 3. So this is how we have solved this particular matrix using matrix method. Let's take another example, right? Say we have linear equations like this, right? There is a small difference here. They put the constants also on the left hand side. 3 and 8 are on the left hand side. So what we have to do in this case is, we'll have to write this equation as x plus 2y is equal to shift 3 here. So it's going to become minus 3. And this one we'll write as 2x minus 3y, shift 8 here. So minus 8 will become plus 8. Now these are the equations, right? Now we'll have to represent this in a matrix form. So first we'll have matrix A, which will have coefficients of x and y. So first write this. So initially we'll get confused, right? So put x and y here, right? Just put the heading x and y so that you don't get confused. Otherwise you might change the order. So, and write these equations in this form, right? Write it vertically. So now there's nothing, means that there is 1 here, right? So coefficient of x is 1. For second equation it's 2. Then y is 2 and then it's minus 3. Remember to put the signs here, okay? You have to include the signs also when you're putting the coefficients here. The reason why I'm writing x and y as heading is, there are possibility that you will swap this entire thing. You can write it like this. Normal mistakes that people do. They will write 1 and 2 this way. That is, they will write coefficient of 1 here and coefficient of this x here. They will write it horizontally instead of writing it vertically. Similarly, you can write it like this, right? Let's not do that mistake. That's why it's better to put this heading x and y initially, right? Until we get enough practice. Next one is, we'll put matrix X. This is matrix of unknowns. That is x and y. Simple, right? There's nothing to think here. Just put x and y. Then next one is matrix B. Matrix B is matrix of constants. What are the constants here? Minus 3 and 8. Minus 3 and 8. See, that's why we'll have to always put these constants on the right hand side. Otherwise, don't get confused and put constants as, since you have 0 here, don't make it as 0, 0. This is wrong. You have to shift these numbers to the right hand side and then put those numbers in this matrix B. So rest everything is the same approach, right? So we'll first, so x is nothing but, let's write down the formula. X is equal to A inverse into B. And to find A inverse, we'll have to write 1 by determinant A into adjoint of A, right? We'll have to use this formula first, get A inverse, substitute A inverse in this particular formula, then you'll get matrix X. From matrix X, we can find the values for X and Y. Same method like we did in the earlier example. Let's take a 3 by 3 matrix and using matrix method, solve the values for X, Y and Z. So let's quickly come up with matrix. Matrix A is equal to 1, 2 and 3. I will write it in vertical form, otherwise it will get confusing. X minus y plus 2z is equal to 3. 2x plus z is equal to 1. 3x plus 2y plus z is equal to 4. Notice in the second equation, y is not there, right? Y is not there. Notice that. So now let's construct the matrix. Matrix A is 1, 2, 3. 1, 2, 3. Minus 1. There is no y in the second equation, so it will be 0. In third equation, you have 2. Let's come to z. X, y, z. What is z? 2. There is nothing here, so we put it as 1. There is no coefficient for z, so we assume it is 1. And here it is 1. Then x, matrix X is x, y, z. Then matrix B is matrix of constants. 3, 1, 4. 3, 1, 4. So we'll have to find matrix X. Matrix X is A inverse into B, and A inverse is equal to 1 by determinant of A into adjoint of A. Now let's find determinant of A. Determinant of A is, we'll take the row which has 0. We'll take this particular row. We'll get 2 into minus 1 into 1, 1, minus 1, minus 4. And what is the sign? Sign is plus, minus, plus, minus, plus, minus. So it's minus 2. Then the next element is 0. Let's ignore. Third element is 1. Minus 1, because we have minus here. Minus 1 into 2 minus 3 into minus 1. 3 into minus 1, which is minus 3. And minus is plus. So plus 3. So we'll get minus 5, 5. So 2 into 5, 10 minus 5. So we get 5 as the determinant. Now, one thing, you'll always have to check if the determinant is 0, right? Remember the singular matrix concept? Remember that key note or key property, right? If you here we have to find A inverse, but not all matrices will have inverse, right? So if the determinant is 0, determinant for this matrix is 0, that means inverse does not exist. But here we have a non-zero number. So determinant is non-zero. This is non-zero. Therefore, A inverse exists, right? So therefore, we can go ahead and find the inverse matrix. So we have determinant A. Now next step, we'll find adjoint A. Adjoint of A. Adjoint of A. Now this is 3 by 3. So it's going to be a lengthy step. So let's put the signs first. Plus, minus, plus, minus, plus, plus, minus, minus, plus. Now let's put the cofactors. What is the first element we have? 1. Cofactors would be 0, 1, 2, 1. 0, 1, 2, 1. The next element is minus 1. Cofactors for minus 1 is, ignore this. So it will be 2, 1, 3, 1. 2, 1, 3, 1. And there is minus here, right? Let's circle all the minus so that we don't forget. Or we can put minus here. Then third element is 2. 2. So for 2, what are the minors? What is the cofactor? 2, 0, 3, 2. 2, 0, 3, 2. Let's go to fourth element. Fourth element is this one, 2. So ignore this row and this column. So you'll get minus 1, 2, 2, 1. Minus 1, 2, 2, 1. Now we'll continue this way and we'll get all the cofactors. Now we'll have to calculate, right? Cross multiply and calculate everywhere. So let's calculate it here itself in this same matrix. 0 minus 2. So you'll get minus 2 here. Then 2 minus 3. 2 minus 3 is minus 1 and there is already a minus here. So it's going to be plus 1. Then 2 2s are 4. 4 minus 0. So you'll get 4. Let's come to this. Minus 1 into 1 is minus 1. Minus 1 minus 4. So it's minus 5. And there is already a minus here. So it's going to be plus. It's going to be plus 5. Then 1 into 1 minus 6. That is minus 5. Then 1 into 2, 2. 2 minus minus 3. So it's going to be minus 5. Minus here. So it's minus 5. Next one is minus 1 into 0. Minus 1 plus 0. This one is 1 minus 4. 1 minus 4 is minus 3. And there's already a minus here. So minus of minus 3 is going to become plus 3. The next one is 0 minus of minus 2. So it's going to be plus 2. Now, remember that this has to be a transpose. Never forget this. We'll have to take a transpose here, right? Now let's write this in the neat form. We'll get minus 2, 1, 4, 5, minus 5, minus 5, minus 1, 3, and 2. And then take a transpose of this. So we'll interchange the rows and columns. So minus 2, 1, 4, minus 2, 1, 4, 5 minus 5 minus 5. Write it as column. Minus 1, 3, 2. Minus 1, 3, 2. So we've taken the transpose. So this is adjoint of A. We have this. What is the next step? Next step is finding A inverse. A inverse is 1 by determinant A into adjoint of A. Correct? Let's substitute. A inverse is 1 by determinant A. What was determinant of A? 5. 1 by 5 into adjoint of A. That is minus 2, 5, minus 1, 1, minus 5, 3, 4, minus 5, 2. Now we'll leave it like this because there's no point multiplying. You're going to get fractions everywhere. Let's leave it like this for time being. We'll go to the last step, which is x is equal to A inverse into B. Now we'll substitute. X is equal to A inverse is 1 by 5 into this entire matrix. We'll just copy this. 1 into matrix B. Matrix B is constants, right? Constant matrix. 3, 1, 4. 3, 1, 4. Let's copy this. 3, 1, 4. Now let's do matrix multiplication. Let's multiply these two matrices and then multiply with 1 by 5. So let's multiply 1 by 5 into, let's multiply. So this is 3 by 3 and this is 3 by 1. So final order should be 3 by 1. That is, you take this row count and the column count of this. So 3 by 1. This is the final order. Right? So you'll have 3 rows. You'll have row 1, row 2, row 3 and 1 column. So let's multiply. Minus 2 into 3 is minus 6 plus 5 into 1, 5. Minus 1 into 4, minus 4. 1 into 3, 3. Minus 5 into 1, minus 5. 3 into 4, 12. 4 into 3, 12. Minus 5 into 1, minus 5. 2 into 4, 8. Right? Now we'll write it as, we'll get minus 5. Minus 2 plus 12 is 10. 20 minus 5 is 15. So now it becomes easier to multiply because you have all multiples of 5 here. Right? That's why I said initially itself, let's not convert this into fractions. We could have made this as minus 2 by 5. Minus 2 by 5, 5 by 5, minus 1 by 5. We could have populated all the elements by multiplying with 1 by 5. We left it as is because the last step, it will be easy to simplify. Right? So now we will get 1 by 5 into minus 5. So this will get cancelled. So you'll have minus 1. 1 by 5 will get 2. 1 by 5 into 15, you'll get 3. So this is matrix X. Matrix X is minus 1, 2, 3. Now what is matrix X? Nothing but X, Y, Z. Correct? Which means X is equal to minus 1, Y is equal to 2, Z is equal to 3. Right, this way. So these are the values of the unknowns or variables. So we have come to the end of this particular topic. Do press the like button if you have liked this video, and thanks for watching.